Dear students, welcome. This will be our class number 17 on statics. Today we shall solve some problems on the moments of a force about it. Question number 17. Three forces PQR act along BC, CA, AB of a triangle ABC. If their resultant passes through, there are four questions here. Passes through the centroid G of the triangle ABC. Then we have to choose this. Passes through the centroid. And if the resultant passes through the incenter of the circle, then P plus Q plus are equal to 0. And if the resultant passes through the circumcenter of the triangle, then P cos A plus Q cos B plus R cos C equal to 0. And if the resultant passes through the orthocenter of the triangle, then we are to prove this one. Of course, you should remember these four results. BCCAAB. BC can be replaced by small a, and it is nothing but small b, small c. P by small a plus Q by small b equal to R plus R by small c. This is equal to 0. If the resultant passes through the incenter of the triangle, then P plus Q plus R equal to 0. If the resultant passes through the centroid of the triangle, then P by A small a plus Q by small b plus R by small c equal to 0. From this result, you will immediately reduce this one. P by sin A plus Q by sin B plus R by sin C equal to 0. If the resultant passes through the circumcenter of the triangle, then P cos A plus Q cos B plus R cos C equal to 0. And if the resultant passes through the orthocenter of the triangle, then we have to prove this one. Now let us try to solve question number 1. The centroid of the triangle. The centroid of the triangle. Resultant passes through the centroid of the triangle. Resultant passes through the centroid of the triangle. Suppose ABC is the triangle. Passes through the centroid. Suppose this is the midpoint of this BC. Join. This is the midpoint of BC. Join AD. And suppose that Z is the centroid of the triangle ABC. Z is the centroid of the triangle ABC. And forces PQR are acting along this and R. PQR are acting along this. Let the forces PQR are acting along BC, CA, AB of the triangle ABC. Let the forces PQR are acting along BC, CA and AB of the triangle. It is given. It is also given in the question. Let D be the midpoint, middle point. D be the middle point of BC, and let G be the centroid of the triangle. The centroid of the triangle. G be the centroid of the triangle. Notice that the resultant passes through the centroid G. Therefore, moment of the resultant about the point G should be equal to 0. We are going to apply the Verigne's theorem on moment. The algebraic sum of the moments of three forces or any forces about any point is equal to the moment of their resultant about the same point. Since the moment of the resultant about G is 0, therefore the algebraic sum of the moments of the forces about G should be equal to 0. should be that is Verigron's theory. Now, what is the moment of a force about a point? Suppose this is a force. This is a force. About a point this, you have to multiply two things. Number one, suppose this is a force F. The magnitude of the force F, and about the point this, just multiply the perpendicular distance. Suppose it is small d. Perpendicular distance from the point to the line of action of this force. Magnitude of this force into the perpendicular distance this. If you are going to apply the Verigron's theory one moment, then the force P into perpendicular distance from Z on the line of action of the force P. Therefore, you have to draw the perpendiculars. Such draw, therefore let G, suppose this is GM. GM. Also, suppose it is GM are perpendiculars. Let GM are perpendiculars. From Z on BC, CA and AB respectively. BC, CA and AB respectively. Now, since the resultant passes through the centroid G, of the triangle, G of the triangle ABC. Therefore, by Verigron's theorem on moment, taking moment of the forces about Z we get P into ZL plus Q into ZM plus R into ZM equal to 0. Why it is equal to 0? This is equal to the moment of the resultant about the point G. Since the line of action of the resultant passes through the point G, therefore the perpendicular distance from the point G on the line of action of the resultant will be equal to 0. Therefore, the moment will be equal to 0. That's why the right hand side becomes 0. Now, the forces are about G. You see, about G. It has a tendency to rotate this in anti-clockwise direction. If it has a tendency to rotate the body in anti-clockwise direction, then you should take the moment as positive. And if it has tendency to rotate the body in clockwise direction, then you should take the moment as negative. Now, about the point Z, P, Q, R, all will rotate this in anti-clockwise direction. Therefore, all the signs have been taken as positive. Yeah. By Verigron's theorem on moments, this is the moment of the force P about the point Z. This is the moment of the point Q about the point G. This is the moment of the force R about the point G. Perpendicular distance. This magnitude of the force and the perpendicular distance. That's very simple. Now, now we shall derive this from this one. Now, draw perpendicular AS. Suppose AS. We draw perpendicular AS. AS from A on BC. We draw perpendicular AS from A on BC. Right? Now, triangle GLD and triangle ASD are similar. Why? You see, GL is perpendicular on BC, AS is perpendicular on BC. Therefore, this angle is 90 degree, this angle is also 90 degree. And GDL is equal to ADS. Consequently, two angles are same. Consequently, the third angle will also be same. This angle, LGD, and this SAD will also be same. Therefore, the two triangles are similar. Therefore, GL divided by AS, GL divided by AS equal to GD divided by AD should be equal to 1 by 3. This means GL equal to 1 by 3 AS. 1 by 3 AS. GL equal to 1 by 3 AS. You will get this one. Now, let delta equal to area of the triangle ABC. This means delta equal to half base into altitude. Base pane BC, altitude AS. BC into AS. Half base into altitude. Base into altitude. This means AS half base into altitude. AS is equal to twice delta divided by BC. Twice delta divided by BC. Suppose this is number 2 and this is number 3. From this is number 3. 2 and 3, from 2 and 3, this delta stands for the area of the triangle ABC. From 2, GL equal to 1 by 2 and 3, from 2 and 3 you may write 2 and 3. GL equal to 1 by 3 AS equal to twice delta divided by 3 BC. 3 BC. 3 BC. Similarly, GL equal to 2 delta by twice BC. Similarly, GM equal to what? GM will be equal to 2 the area of the triangle divided by 3 into CA. You will CA and GM equal to 2 delta divided by 3 AB. 2 delta divided by 3 AB. You will get this one. Therefore, from 1 you will get. Therefore, 1 is right. From 1 you will get P into GL. GL means, we can write GL means 2 delta divided by 3 BC. GL means 2 delta divided by 3 BC plus Q into GM means 2 delta 3 CA plus R 2 delta divided by 3 AB. should be equal to 0. This means 2 delta by 3 will be cancelled from all sides. P by BC plus Q by CA plus R by AB should be equal to 0. R by AB should be equal to 0. Now, this means P by A, Q by B plus R by C should be equal to 0. This proved. Should be equal to 0. Now, A by sin A equal to B by sin B equal to C by sin C equal to twice R equal to K say. Suppose this is equal to K. This means A equal to K sin A. Twice R sin A means K sin A. B equal to K sin B. C equal to K sin C. Therefore, put here K sin A or twice R sin A plus Q divided by K sin B plus R by K sin C equal to 0. This means P by sin A plus Q by sin B plus R by sin C should be equal to 0. R by sin C equal to 0. Therefore, we have proved number 1. This means that if the resultant passes through the centroid of the triangle, then P by small a means BC, P by BC plus Q by CA plus R by AB equal to 0. From this, you can reduce P by sin A plus Q by sin B plus R by sin C equal to 0, or P cosec A plus Q cosec B plus R cosec C equal to 0. You may write like this also. P by sin A means you may write P cosec A plus Q cosec B plus R cosec C. Now come to the question number 2. If the resultant passes through the incenter of the triangle, perhaps you have understood this one. It is very easy. Thus, let me remove this. If the resultant passes through the incenter of the triangle, passes through the incenter of the triangle, incenter of the triangle, resultant passes through the incenter. ABC. And another I is the incenter of the triangle. I is the incenter of the triangle. You see, I. PQR are acting along PQR and R are acting along BCCA and AB. I is the incenter of the triangle. You see, BC is a tangent at this point. If you draw this line ID, it must be the perpendicular. It must be perpendicular on BC. It must be normal. It is tangent means it is normal. It will be normal. The perpendicular. Now the forces PQR are acting along BCCA and AB of the triangle ABC respectively. of the triangle ABC respectively. Now, let I be the incenter of the triangle ABC. Let I be the incenter of the triangle ABC. Let ID, IE, IF are perpendiculars on BCCA and AB. BCCA and AB respectively. Perpendiculars on BCCA and AB respectively. Now, since the resultant of the forces PQR passes through the incenter of the triangle, Therefore, by Derrida's theorem on moments, we get P into ID plus Q into IE plus R into IF should be equal to 0. These are the moments along it will try to remove rotate the body in anti-clockwise direction. So all the forces will have tendency to rotate the body in anti-clockwise direction. All the moments have been taken positive. P into ID plus Q into IE plus R into IF. This is equal to, by Derrida's theorem on moments, the moment of their resultant. Since the resultant passes through the point I, the incenter, therefore, the perpendicular distance from I on the line of action of the resultant should be equal to 0. Consequently, the moment of the resultant about the point I, about the incenter, is equal to 0. Therefore, left side will be again 0. Now, this will be equal. This means PR plus QR plus R into small r equal to 0. Where R is, where you may write here, where ID equal to IE equal to IF equal to R equal to in radius of the triangle ABC. In radius of the triangle ABC. This means that P plus Q plus R equal to 0. This means that P plus Q plus R should be equal to 0. We have proved the question number 2. We have proved, first we proved the question number 1. The question number 2 has also been proved. Perhaps you have understood. This is very easy. Now, come to the third question. Circumcenter of the triangle. Circumcenter. Number 3. The resultant passes through the circumcenter of the triangle. ABC. Passes through the circumcenter. Suppose ABC is the triangle. O is the O is the is the circumcenter. O is the circumcenter of the triangle. OD, OE, and OF. Are perpendiculars. OD, OE, and OF are perpendiculars on BCCA and AB respectively. Now, suppose this is O. Yeah, I am writing here O. Suppose this is O. Now, the forces PQ are acting along this. The forces, number 3, we are to the forces PQR are acting along BCCA and AB respectively. Let O be the circumcenter. Let O be the circumcenter of the triangle ABC. Let O be the circumcenter of the triangle ABC. Let O be the circumcenter of the triangle ABC. Let OD, OE, OF are perpendiculars on BCCA, CA and AB respectively. AB respectively. Since the resultant passes through the point O, therefore the moment of the resultant about the point O is equal to 0. Since the resultant of PQ and R, since the resultant of PQ and R passes through the circumcenter O of the triangle. Therefore, moment of the resultant about O should be equal to 0 or will be equal to 0. Moment will be equal to 0. Moment of the resultant about O will be equal to 0. Therefore, by Varignon's theorem on moments, algebraic sum of the moments of PQR about O should be equal to 0. Therefore, by Varignon's theorem of moment, theorem on moment, the algebraic sum of the moments about O is equal to 0. P into IOD plus Q into OE plus R into OF equal to 0. Suppose this is number 1. Algebraic sum of the moment of the forces about the point O. This is equal to the moment of the resultant about the point O. Since the moment of the resultant about the point O is 0, therefore the algebraic sum of the moment of the force P about the point O is equal to magnitude of the force P into perpendicular distance from O on the line of action of the force P and the Q, the magnitude of the force Q, into perpendicular distance from the point O on the line of action of the force Q is equal to 0. Plus this should be equal to 0. Now OD, we have to find. Now what is OD? In terms of angle A, we have to find this one. Now OD. Now OD equal to OB cos of this angle, BOD cos of angle BOD, right? This by OB equal to cos of angle this. Or you may write OD equal to R cos of angle BOD, where R is the circumradius, where R equal to circumradius of the triangle ABC. Circumradius of the triangle ABC. Circumradius of the triangle ABC. Right? Now, consider the triangle. Triangle BOC, OB equal to OC equal to circumradius. Therefore, OBD, this angle, will be equal to OCD. These two sides are equal, therefore these two angles will be also equal. OD ODB equal to ODC equal to 90 degree. Equal to 90 degree. Therefore, from triangle OBD and ODC, from triangle, these two triangles, these two angles will be equal. These two angles, these two triangles, this angle equal to this angle, this angle equal to this angle. Therefore, the remaining two angles will also be equal. We have what we have, BOD equal to COD. BOD equal to COD. Now this is number, suppose this is number COD. Therefore, BOD should be equal to half of BOC. BOD should be equal to half of BOC. Because this plus this equal to BOC. This plus this means 2 times of BOD equal to BOC. Therefore, BOD equal to half of BOC. Therefore, from 2 you will get. From 2 implies OD equal to R cos half of BOC. Half of angle BOC. Now you see, in a triangle, this the angle made by this, or this angle will be equal to half of this angle. Will be equal to half of this angle. This is equal to 2 times of this angle. This is equal to 2 times of this angle. This angle is equal to 2 times of angle A. Now you see, this makes an angle, this BOC at the center O, and it makes an angle A. Yeah. Therefore, BOC should be equal to 2 times of A. BOC equal to 2 times of A. Means OD equal to R cos half of 2 times of A. This means OD equal to R cos A. R cos A. OD is equal to R cos A. Similarly, we can prove that. Prove that OE equal to R cos B. This OD equal to R cos A. It will be R cos B. OF should be equal to R cos C. R cos C. Therefore, from 1 we will get, means 1 implies P into OD R cos A plus Q into R cos B plus R into R cos C should be equal to 0. P cos A, Q cos B, R cos C should be equal to 0. Proved. We have proved this one. Thus, if the resultant passes through the circumcenter of the triangle, then P cos A plus Q cos B plus R cos C equal to 0. Now come to the last one. We have proved this one also. The orthocenter of the triangle. The orthocenter of the triangle ABC. If the resultant passes through the orthocenter of the triangle, then we have to prove that P sec A plus Q sec B plus R sec C equal to 0. Now, perhaps you have understood this one. It is very easy. Orthocenter. Number 2. The orthocenter X of the triangle ABC. Suppose ABC is the triangle. Orthocenter ABC is the triangle. Thus, the draw perpendiculars AD, also BE. PQR forces acting along this. ABBC CA of the triangle ABC. PQR forces acting along ABBC CA of the triangle ABC. AD, BE, and they meet at the point X. X is the, by definition, X is the orthocenter of the triangle. The resultant passes through the orthocenter, then this one. The forces PQR are acting along BC, CA and AB. CA and AB of the triangle ABC. BC, CA and AB of the triangle ABC. The forces PQR are acting along BC, CA and AB of the triangle ABC. Of the triangle ABC. Now, let AD, BE, CF are perpendiculars. These perpendiculars on from A, B, C respectively on BC, CA, AB respectively. BC, CA and AB. Let X be the orthocenter of the triangle. Orthocenter. Triangle ABC. Orthocenter of the triangle ABC. Since the resultant passes through the orthocenter, since the resultant passes through the orthocenter X of the triangle, ABC, therefore, by Varignon's theorem on moments, P into XD plus Q into XE plus R into XF should be equal to 0. By Varignon's theorem on moments, since the resultant passes through the orthocenter, therefore the moment of the resultant about the orthocenter is equal to 0. By Varignon's theorem, we have got this one. Suppose this is number 1. Now, XD. Yes, XD. Now, triangle BXBD from triangle XBD XD divided by BD equal to tan XBD. This angle tan XBD. This means XD equal to BD tan XBD. Suppose this is number 2. Now, you see XBD equal to EBC. Angle XBD equal to EBC. Angle EBC. XBD equal to EBC. Now consider the triangle BEC. Consider the triangle BEC. Triangle BEC. Consider the triangle BEC. This angle is 90 degree. Angle is 90 degree. BEC equal to 90 degree. Therefore, EBC equal to 90 degree minus ECB. ECB equal to 90 degree minus ACB. This is equal to 90 degree minus C. 90 degree minus C. Now, EBC equal to, that is, since EBC equal to XBD, that is angle XBD equal to 90 degree minus C. From 2, therefore 2 implies XD equal to BD tan, it is 90 degree minus C, tan 90 degree minus C. This means XD equal to BD, it is cot C. Suppose this is number 3, this is cot C, number 3. Now you consider the triangle ABD. Now from triangle ABD, from right triangle ABD, BD divided by AB equal to BD divided by AB equal to cos ABD. This means BD divided by AB can be written as small c equal to cos, it is nothing but angle B. This means BD equal to C cos B. C cos B. Therefore, from 3 you will get. Therefore, 3 implies XD equal to BD means C cos B. Cot C. C cos B, cot C. C cos B, cot C. XD equal to C cos B, cot C. Similarly, XE, you see, XD equal to C means the left side, this side, C, cos of angle B into cot of angle C. Therefore, XE will be equal to left side, this angle will be equal to A. Cos of C into cot of A, into cot of A, and XF should be equal to XF left side AC, the side AC will be equal to B. B cos of this angle A into cot of angle B. Therefore, from 1 we get. Therefore, from 1 you will get. Therefore, 1 implies P XD. For XD, you write this one. C cos B. C cos B cot C plus Q XE A cos C cot A plus R. It will be B cos A cot B. This means P, it will be K sin C, you may write K sin C cos B cos C by sin C plus Q. K means twice R sin A cos C cos A by sin A plus R. B means K sin B cos A cos B by sin B, cos B by sin B. You will get this one. Since we have applied this, A by sin A equal to B by sin B equal to C by sin C equal to twice R equal to KC. Equal to KC. We will get this one. Now K will be cancelled. Also sin C will be cancelled. It will be sin A will be cancelled. Sin B will be cancelled. K also will be cancelled. It will be this will be equal to 0. Will be equal to 0. This means that P cos B cos C, KK will be also cancelled. P cos A cos B cos C divided by cos A plus Q cos A cos B cos C divided by cos B plus R cos A cos B cos C divided by cos C equal to 0. K will be cancelled from both sides. Divide by K. Divide by K. This means P by cos A plus Q by cos B plus R by cos C equal to 0. Plus R by cos C equal to 0. You will get this one. P by cos A plus Q by cos B plus R by cos C equal to 0. Or you may write it as P sec A plus Q sec B plus R sec C. Sec C should be equal to 0. P sec A plus Q sec B plus R sec C equal to 0. We have proved all the 4 problems. 4 problems have been solved. Let us take some more problems. Before that, let me remove this. Let us try to solve these 4 problems. 3 forces PQR act along the side BCCA of a triangle if their resultant passes through the incenter and centroid. Then we have to prove this one. Incenter and circumcenter. Then we have to prove this one. Orthocenter and circumcenter. Then we have to prove this one. If the resultant passes through the orthocenter and centroid, then we also have to prove this one. Just we have proved that if the resultant of 3 forces acting along BC, CA and AB respectively of a triangle, and if the resultant, if 3 forces PQR are acting along BC, CA and AB respectively, and if the resultant passes through the incenter of the triangle, then we have established that P plus Q plus R equal to 0. If the resultant passes through the centroid of the triangle, then we have proved that P by small a plus Q by small b, R by small plus R by small c equal to 0. Small a means BC, small b means CA of the side, and small c equal to AB, side of the triangle ABC. Also, if the resultant passes through the circumcenter of the triangle, then we have proved that P cos A plus Q cos B plus R cos C equal to 0. And if the resultant passes through the orthocenter of the triangle, then we have proved that P sec A plus Q sec B plus R sec C equal to 0. Now, the resultant passes through the incenter. The resultant passes through the incenter, right? The resultant, number 1, the resultant passes through the incenter I of the triangle ABC. Therefore, we have P plus Q plus R equal to, suppose this is number 1. Taking moments of the forces about the incenter. Taking moments about, you may write taking moments about I. And applying Ferrignon's theory. Moments about the incenter I, about I. Since the resultant, also the resultant passes through the centroid of the triangle, centroid G of the triangle. Therefore, just as before, P by Q by B plus R by C equal to 0. R by C equal to 0. Now from 1 and 2 solve. From 1 and 2. PQR. P divided by Q divided by R divided by 1 into 1 by C minus 1 into 1 by B, Q 1 into 1 by A minus 1 into 1 by C, 1 into 1 by B minus 1 by A. You will get this one. Or you will get this BC into P, B minus C. AB are A minus B. This means ABC P A B minus C equal to ABC Q B C minus A. This is equal to C minus A. ABC R C A minus B. ABC will be cancelled. Multiply numerator denominator by A. Here B and no. Here B and here C. From all sides, cancel this. This means from this you will get P by A into B minus C. This is equal to Q by B into C minus C. This is equal to R by C into A minus C. You will get this one. Therefore, 1 has been proved. We have proved number 1. We have also used the previous problem, previous question. Number 2. Come to the point, number 2. We have proved number 1. Number 2. What is number 2? Incenter and circumcenter. Incenter and circumcenter. Since the resultant of the forces PQR acting along BCCAAB, PQR passes through the incenter I and circumcenter O of the triangle ABC. Therefore, taking moments about I and O separately, therefore taking moments about moments of PQR of the forces PQR about I and O we get. About I will get P plus Q plus R equal to 0. This is number 1. Circumcenter P cos A plus Q cos B plus R cos C equal to 0. Just we have proved. Now, therefore, from 1 and 2 you will get. From 1 and 2 you will get P divided by 1 into cos C minus 1 into cos B. This is equal to Q 1 into cos A minus 1 into cos C equal to R 1 into cos B minus 1 into cos A. P by cos B minus cos C equal to Q by cos C minus cos A. This is equal to R by cos A minus cos B. R by cos A minus cos B. We have proved the number 2 also. The number 2 has been proved. If the resultant passes through the incenter and circumcenter, then you will get this one. Number 3, if the resultant passes through the orthocenter and circumcenter. Number 3. Number 3. But perhaps you have understood this one. Thus we have applied the previous question. Number 3. Since the resultant. Number 3. Since the resultant. You will have to prove this one. First you will have to prove this one. Any one of this in the examinations, any one of these 4 may be asked. Then first you have to prove this one. Orthocenter and circumcenter. Since the resultant passes through the orthocenter of the triangle ABC. Therefore, P sec A plus Q sec B plus R sec C should be equal to 0. Suppose this is number 1. Also the resultant passes through the circumcenter. Also the resultant. Resultant of the forces PQR acting along BCC AB of the triangle ABC, resultant passes through the circumcenter of the triangle ABC. Of the triangle ABC. Circumcenter of the triangle ABC. Then, therefore, we get P cos A plus Q cos B plus R cos C equal to 0. But cross multiplication system, therefore 1 and 2 implies 1 from 1 and 2, you will get P divided by sec B cos C minus sec C cos B sec C. This is equal to Q divided by sec C cos A minus sec cos C sec A. Should be equal to R divided by cos A sec B minus cos B sec A cos B. Sec A cos B. You will get this one. Right? This means P divided by cos C by cos B minus cos B by cos C equal to Q divided by cos A by cos C minus cos C by cos A equal to R divided by cos A by cos B minus cos B by cos A. Cos B by cos A. Cos B cos C. This means you will get here cos B cos C P cos square C minus cos square B should be equal to cos C cos A Q cos square A minus cos square C. This is equal to cos A cos B R cos square A minus cos square A minus cos square B. Now, let me simplify this. We have to simplify this one. This means cos A cos B cos C. I'm writing here because camera may not cover this. Cos A cos B cos C P, it is cos A. And 1 minus sine square C minus 1 minus sine square B. You may write like this. This is equal to cos A cos B cos C. Cos C Q cos B 1 minus sine square A minus 1 minus sine square C. Sine square C. This is equal to cos A cos B cos C. It will be cos C 1 minus sine square A number 1 CB AC Number one thing, we have done one mistake here. If the only this step, if the resultant passes through the ortho center, then P sec A plus Q sec B plus R sec C equal to 0. Circumcenter means cos A Q cos B plus R cos C should be equal to 0. Sec B cos C minus cos B sec C. We have written like this. Sec C cos A minus cos sec C cos A minus cos C sec A. No mistake here. And last term, sec A cos B. We have just corrected. Sec A cos B. It should be sec A. It should have been sec A cos B minus cos A sec B. It should have been like this. It should have been this. Therefore, it should have been B and A. And here A and here B. Just correct this one. Cos A cos B cos C. Cos A cos B, there will be no problem. It will be cos square B cos square A. Cos square A. And here also, it should, oh no, cos square A. Cos square B, it should have been cos square B. Minus 1 minus cos square, 1 minus sin square. Right? Everything is correct. This time. Just correct this one. We have corrected this. This means divide cos A cos B cos C from both sides. From all sides, it will be cos A. 1 minus 1 will be cancelled. Sin square B minus sin square C. Sin square B minus sin square C. This is equal to Q divided by cos B. 1 will be cancelled. Sin square C minus sin square A. Sin square C minus sin square A. This is equal to R divided by here cos C. Sin square A minus sin square B. Sin square A minus sin square B. This means P by cos A by K whole square a square by k square, you may write like this. C square by, no, b square by k square. It is not a square. B square by k square. C square by k square equal to q divided by cos b. A square by k square minus b square by k square this one, c square by k square minus a square by k square. Now this one r divided by cos c, a square by k square minus b square by k square minus b square by k square. This one. Since, you may write here, since a by sin a equal to b by sin b equal to c by sin c equal to twice r equal to k, therefore sin a should be equal to a by k, kc, sin b equal to b by k, and also sin c is equal to c by k. We have used that. Now k square will be cancelled. This means p divided by b square minus c square into cos a equal to q divided by cos b. C square minus a square cos b. This is equal to r divided by a square minus b square cos c. A square minus b square cos c. We have proved this one also. We have proved question number 3 also. We have proved question number 3. Just now the last one is orthocenter and centroid. If the resultant passes through the orthocenter and the centroid, then orthocenter and centroid. Number 2. Since the resultant passes through the orthocenter therefore P sec A plus Q sec B plus R sec C equal to 0. Number 1. Also the resultant passes through the centroid. Therefore, P by sin A, P by small a or P by sin A, Q by sin B plus R by sin C equal to 0. This is equal to 0. This result can also be written as P cosec A, that is P cosec A plus Q cosec B plus R cosec C equal to 0. R cosec C equal to 0. From 1 and 2, similarly, from 1 and 2, P divided by sec B cosec C minus cosec B sec C. Sec C should be equal to Q divided by sec C cosec A cosec A minus cosec C sec A sec A. This should be equal to R divided by sec A cosec B minus cosec A sec B. Minus cosec A sec B. Suppose this is number 3. Suppose this is number 3. Now, here also, since these questions have been put, therefore, remove this one. Remove this one. Now, this one. Sec B cosec C minus cosec B sec C. Cosec B sec C. This is equal to 1 by cos B into 1 by sin C minus 1 by sin B 1 by cos C. This is equal to sin B cos C minus cos B sin C, sin B cos B sin C cos C. You may write like this. This is equal to sin of B minus C. Here you may write 4, 2 times of sin B cos B and 2 times of sin C cos C. You may write like this. This is equal to 4 sin B minus C. Here you may write sin twice B, sin twice C, or you may write 4 sin twice A, sin of B minus C, sin twice A, sin twice B, sin twice C, or you can write it as K sin twice A, sin of B minus C, where K equal to 4 divided by sin twice A, sin twice B, sin twice C. You may write like this. The denominator of B, yes, is equal to. Similarly, this one, sec C cosec A minus cosec A cosec C sec A should be equal to K into, there is no A, therefore we have got sin twice A. It will be sin twice B, and sin, it will be C minus A. C minus A, and this one, sec A cosec B minus cosec A sec B should be equal to K. There is no C, therefore you will get sin twice C into sin A minus B. A minus, you will get this one. Suppose this is number 4, 5 and 6. 4, this is 5 and this is 6. This is 6. Using 4, 5 and 6 in 3 we get. Using 4, 5 and 6 in 3 we get. Using 4, 5 and 6 in 3 we get. 4, 5 and 6 in 3 we get. P divided by, it will be K sin twice B sin B minus C. This is equal to Q divided by K sin twice B sin C minus A. This is equal to R divided by K sine twice C sine A minus B. K will be cancelled. Finally, you will get sine twice B. No, it is sine twice A. It is not sine twice B. Sine twice A. Sine twice A. Sine twice A. Sine B minus C equal to Q divided by sine twice B sine C minus A equal to R divided by sine twice C sine A minus B. Sine twice C sine A minus B. Therefore, we have proved this problem also. We have proved all the four conditions, four problems. Therefore, we have proved this one also. Dear students, I will finish by solving one more problem. Let me first remove this, then let us try to solve this problem. What is it? A uniform plank of length twice A and weight W. Let me write it here. The figure. AB is the plank. G is the center of gravity. Two props are there. R and S are the normal direction. R and S are the normal directions at P and Q. Now W1 is placed here. Then it is about to be upset about the point Q. This is suppose number figure 1. This is figure 1. Figure 1. Also, the same thing, AB, the props are there, P and Q, props are there, it is S, it is R, and the W is acting vertically downwards through the center of gravity. Now, W2 is placed at the point B. It is about to be upset about the point P then. This is figure 2. Now, this is figure 2. You see, AB is the uniform plank of length twice. AB is the uniform plank such that AB equal to twice A. AB equal to twice A. The weight W of the plank acts vertically downwards through G. Downward through G. What is G? The middle point of the plank. Point of the plank. The middle point of the plank. The middle point of the plank. Right? Now, let R and S be the normal reactions of the two vertical props, of the two props, at P and Q respectively. P and Q respectively. right? Now, if W1 is placed at A, if the weight W1 is placed at A, see the figure 1, then the plank is about to be upset, then the plank about to be upset, about the point Q, about the point Q, about the point, about to be upset about the point Q. Therefore, S is equal to 0. S is equal to 0. Taking moments of the forces, about P we get, about P we get, about P you see, W1, it will move in anti-clockwise directions. We'll take it as positive, W1 into AP plus 0 about the point means RA into 0, and W, it will try to rotate in clockwise directions, therefore we will take it as negative sign, minus W PG. This means W1 AP equal to, this is equal to 0, W PG. Suppose this is number 1. Suppose this is number 1. Now, if the weight W2, now, if the weight W2 is placed at the point B, if the W2 is placed at the point B, then the plank is about to be upset about the point, about to be upset about the point P. Therefore, it is from figure 2. It is figure 1 by B, you may write figure 2. See the figure 2. Yeah. About to be about the point, then R is equal to 0. Or then R is equal to 0. Taking moments of the forces about Q we get. Taking moments of the forces about Q we get. About Q. Minus W into QB equal to plus S into 0 plus W, because it will try to rotate in clockwise direction, but it is trying to rotate in anti-clockwise direction. Therefore, it will be taken as positive and this will be taken as negative. ZQ equal to 0. This means that W into Z, W2 QB equal to W into ZQ. Suppose this is number 2. This is number 2. Right? Now, from 1 replies. W1 into AP equal to W into PG. This means W PG by AP equal to PG by AP equal to W1 by W. W1 by W. This means that PG by AP plus 1 equal to W1 by W plus 1. W1 by W plus 1. This means that PG plus AP divided by AP equal to W1 plus W divided by W. This means that PG plus AP, you see, PG plus AP means AG. It is AG by AP equal to W plus W1 divided by W. Or it is A by AP equal to W plus W1 divided by W. W plus W1 divided by W. Now, this means what is AP? AP is equal to AW divided by W plus W1. Suppose this is number 3. Number 3. And AP and it is BQ. BQ. Again, 2 implies QB or QB GQ should be equal to QB means W2 by W should be equal to this from 2. This means GQ by GB, QB plus 1 equal to W2 by W plus 1, or I am writing here, or you may write GQ plus QB divided by QB equal to W2 plus W divided by W. W2 plus W divided by W. GQ plus QB means GQ plus QB means GB. It is GB. QB, this is equal to W plus W2 divided by W. This means it is nothing but again A. QB equal to W plus W2 divided by W. This means QB equal to AW. AW divided by W plus W. W plus W2. Suppose this is number 4. This is number 4. Now, 3, this is number 4. Now, adding 1 and 2 we get. 1 and 2, yeah. Adding 1 and 2 we get. 1 plus 2 implies. 1 plus 2, this implies W1 AP plus W2 QB equal to W PG plus W GQ, or you may write W1 AP is equal to this one, AW divided by W plus W1 plus W2 QB means AW divided by W plus W2 should be equal to W PG plus GQ. Using 3 and 4. Using 3 and 4. Using 3 and 4 you will get this one. Right? Now you may cancel W from both sides. Then you will get AW1 divided by W plus W1 plus AW2 divided by W plus W2 should be equal to PG plus GQ equal to PQ. This is PQ is given to be equal to B at the distance B apart. The distance between P and Q is B. This is equal to B given. This is equal to B given. This means that dividing by A, W1 by plus W2 by W plus W2 equal to B divided by A, dividing by A, proved. B divided by A. So W1 by W plus W1 plus W2 by W plus W2 equal to B by A, proved. Dear students, in total we have solved, practically we have solved 9 problems. Today, I want to stop here. Thanks for attending the class. Thank you very much. Thank you.